Since time immemorial, we have been studying about the solar system. So, in the meantime, in 2006, if you remember, Pluto got demoted to the status of a dwarf planet. We have rovers running and rumbling all over the Martian surface. Recently, you might have heard about the China's Chang'e mission, which successfully landed right around the South Pole, that is on the far side of the moon. There was also Transformers movie, Dark of the Moon. We'll discuss somewhat if we have time. And so, despite all these discussions, all these technical discoveries that we have made, still we have a lot of shadows which are still playing charades with us, and we need to discover about them. And recently, there has been a phenomena in the news, a lot has been talked about, and that is known as the solar storms. So, what exactly is this phenomena? I'll explain in brief and I'll also then demonstrate with the help of diagrams. We'll discuss somewhat about the solar eclipse, the phases of the moon, and what importance Chang'e mission is. Now, the thing is that there are a lot of important, even Chandrayaan 2 had an made an attempt, made a valiant attempt to explore the dark side of the moon. What is so particular about the dark side of the moon? Before that, solar storms we'll be discussing. So basically, for understanding that, first we need to understand or comprehend the structure, the overall structure of the sun. So I'll quickly draw a rough diagram. So this is a random diagram. It looks quite a familiar sight, like it resembles the core of the Earth, but it is not so. I'll just label the parts so it becomes easier for you to understand. So this basically is the core of the sun. Basically, it consists of the two prominent gases, hydrogen and helium, which act as the fuel for providing all of the energy of the sun. They combine together by a process known as nuclear fusion, which powers the sun, and in turn, it helps sun become the entire source of heat and light for the solar system. Okay, then this is known as the radiative zone. Basically, there are three types of mechanisms by which heat transfer take place. If you remember your NCRT in school, one is conduction, one is convection, and one is radiation. So here, basically, radiative zone is there, and this is the photosphere. Photosphere refers to the layer which can be directly observed. Okay, the deepest layer which can be directly observed. This is the chromosphere, and this is known as the corona, which is the talk of the town. It is not corona bear, it is not coronavirus. Basically, again, with me, we focus on the definitions. So, corona is basically it is a layer of charged particles, charged or ionized particle, and these have great temperatures. This layer has very high temperature, And you might have studied about the basic three states of matter: solid, liquid, and gas. This state, this coronal layer, which is observable only during a total solar eclipse, this is ionized in nature, and this attains a new state, a different state known as plasma. You might have heard across. Okay. So this is the coronal, this is the structure of the sun. I'll show you an actual diagram also, much more professional one. So basically, now what is happening is, because of all this charge and high energy particles, the sun sometimes radiates, or sometimes always it radiates the particles from the ionized charged particles from the corona towards the other planets of the solar system, particularly Earth, in the form of what is known as solar wind. Okay. Now, again, for those who have studied the 11th class physical geography NCRT, solar wind was responsible for blowing off most of the gases, the lighter hydrogen and helium gases, which led to the formation of the smaller terrestrial planets in the vicinity of the sun. And that is why we have the rocky terrestrial planets, which are denser but smaller in size as compared to the Jovian or the gaseous planets such as Saturn and Jupiter. So this is solar wind. Now let's move on to the next diagram to understand what exactly is now happening. So this, now I'm drawing a regular sun. So just like we know that the earth behaves like a bar magnet, there are also the magnetic field lines emanating in the sun. So they move somewhat like this. They have a particular direction. Okay. So this is the general. But the sun is also found to be rotating. The sun also rotates. So normally what happens is, or what we assume is, when we consider all the phenomena on the surface of the earth, we assume the sun as a constant. Okay. But it is not so with respect to the universe. So due to its rotation, these magnetic field lines, these magnetic field lines, they get tangled. Fine. And when they get tangled, they sometimes eject a part of the solar material out into the universe or the solar system once they reach a critical point. And this, due to magnetic lines, the emanation or the discharge of the material of the sun is also known as solar flare, or also CME. The full form is coronal mass ejection. Fine. Now, the thing is, when we consider our planet Earth, right? Okay, I'm just drawing some land masses to make it a bit presentable. Okay, no other reason behind it. So, Earth, like I said, Earth also has a magnetic field. So, here what is happening is, it behaves like a bar magnet, and the magnetic field lines are going inside the earth in this direction, then they are going out in this direction. Okay, so they are escaping or exiting the magnetic south pole, or the magnetic south pole, and entering the north magnetic pole. And now we had already observed that there is a stream of charged ionized particle from the corona, which are being emanated by the sun, and these charged particles, they interact with the magnetic field lines of the earth. And here, the magnetic field lines along the magnetic north pole and the magnetic south pole are the strongest. And that is why sometimes we observe a phenomena known as aurora borealis or the northern lights and aurora australis or the southern lights. Basically, you might have observed in the North Pole or in the Scandinavian countries like Norway, Sweden, Iceland, Finland, colored skies. I'll show you some images also. The pink colored skies, the green colored skies. So that is due to the interaction of the solar wind with the magnetic field. There is a layer which is defined or named, christened as the magnetosphere of the Earth, where the magnetic field of the Earth is prominent, and that magnetic field interacts with the solar wind or the charged particles. The gases such as nitrogen and oxygen elements contain electrons. So electrons, when interacting with the solar wind, they get charged, and the electrons go to a higher state. It's just a little bit of chemistry. And then while going back to their normal state, they emit wavelengths of light in the form of photons, and that wavelength is what appears to us in the form of colors, different colors. Now, the point is, this is a normal phenomena. But these solar winds, these solar storms, coronal solar flares, coronal mass ejection, solar storms, they are often used in conjunction. But solar wind, by definition, is simply a stream of charged ionized particles coming from the sun. Whereas solar storm occurs when the solar wind, it's a manifestation of the interaction of the solar wind with the magnetosphere of the earth. You have to understand the difference. So this is what is producing the phenomena. Now what is happening is, recently what has been observed, especially in 2024, that the solar storms, 2024, the solar storms have become particularly very intense, fine. And the phenomena of auroras have has been witnessed as far as Ladakh. Also in Ladakh we have an observatory in Hanle, and that has also observed the auroras. And in America, a lot of places, this is a phenomena. Aurora is particularly a phenomena of the higher latitudes, but this has recently, because of the high intensity of the solar storms, this phenomena aurora has been observed in lower latitudes also. So that is why it is important, not from the only the point of view of prelims, but also means 2024. Because either you consider GS1 or GS3, science and tech or geography, there has been a lot of questions in the past regarding space, IRNSS and Chang'e missions. Lot of missions are, you need to, I'll not discuss the mission to the dark side of the moon much in detail, but you need to understand how the near side of the moon differs from the dark side of the moon, and why we only see only one half of the moon. There is a term known as tidal locking. Then the difference in the Maria are the planes on which the lava floats. So apparently there, in the dark side of the moon, there are less number of Maria, there are more number of craters. So coming back to this, so this is the phenomena. Now, if we go back, we talked about this, the solar flare or the coronal mass ejection. There's some definitions which we need to understand. So there is a solar cycle which spans a period of about 11 years, in which the sun's magnetic field or the intensity of the magnetic the coronal mass ejections, it reaches a maximum, and then it wanes and reaches a minimum. So the last solar cycle, this 2024, marks the middle of one of the solar cycles. So currently it is in the maximum stage. That is why we are witnessing maximum amount of magnetic activity inside the sun. Now, some of the terms which you need to remember, one is the sunspot. Okay. So, what are sunspots? I'll just write the keywords. These are the dark appearing areas on the sun. So, they are basically dark in color. Now, the reason behind this is in these sunspots, these are relatively cooler. Why? Because here in some areas which are known as sunspots, here the magnetic field of the sun is so strong that it prevents the heat from flowing outside. Okay, so that is why they are cooler in nature. And adjacent to these sunspots, because there is a lot of magnetic activity takes place, so adjacent to the sunspots there is a massive intensity or release, high release of energy. So during the maximum period of a solar cycle, the number of sunspots increase, and so does the tangling or the intertwining of the magnetic field lines, and thus more the ejection of the coronal mass. Coronal mass injection intensity frequency increases, and thus the intensity of the solar flares. Okay. Now the important effect, why are we considering, why are we so obsessed with solar flares? Because when they interact with the earth's magnetosphere, if the intensity of solar flares is very high, it can cause power blackouts, it can hamper the communication satellites. Fine. And such other effects. So recently, power outages in many cities of America had been observed. So this is, and then there are different classes of solar flares depending upon the intensity, the flux, which is known as, it is measured in watt per meter square. So there are some categories like B, C, M, X. So out of these, X is the solar flare. X is the solar flare which is considered to be of maximum intensity. M class of solar flares are normally we have observed, but this time due to the solar maximum, there have been instances of the solar flares. Fine. Now coming back to the main topic, some aspects I would like to discuss about the a solar eclipse, because it has been also in the news in April and May. Fine. So this is just the contents. So the solar cycle and the solar cycle we have already understood the comparative study, and this Aditya L1, the satellite, this you might have come across. This Aditya L1 was in news. Have you heard of this term, the Lagrange points? Right? So we'll discuss somewhat in brief. And finally, the most interesting aspect of this is the solar eclipse. Okay, we'll discuss in brief. You'll find it interesting. Phases of the moon, I'll just talk in brief about it. So basically, we know that the moon takes around a month to orbit around the earth. Okay, and due to the position of the sun, moon, and earth, we observe various phases. So when the sun, the new moon is observed when the moon lies between the sun and the earth. So the sun casts a shadow, the moon casts a shadow due to the light of the sun on the earth. So moon is actually there, but we don't observe the light reflected from the moon. Moon appears dark, so it is new moon. We'll come to the solar eclipse. This is not solar eclipse. The reason I'll explain. And when it moves towards this, you might have heard of these terms, the waxing crescent. This means that the size of the moon is increasing. Now, the angle is such that some of the light which is falling on the moon, it is getting reflected to the earth, and we observe the crescent, observe greatest crescent shape. Then first quarter, half moon, then gibbous moon, full moon or Purnima, then waning gibbous, because waning means decreasing in size, waxing means increasing in size. Then last quarter, and finally waning crescent and new moon, Amavasya. Okay, so this is the basic concept. So this is again an illustration. You can just pause the video and see what it. Okay. So different types of solar eclipses you might have heard about. Total, basically four types: total, annular, partial, and hybrid. Now the geometry or the physics behind this is interesting. So we'll discuss a bit about that before I show you the diagram. So basically, again, if I so some revision you will also get from the. Now, simple physics, I'll draw just some ray diagrams. So basically, we can draw some lines of incidence where the sun's rays they meet. Okay. So in this way, we can draw. Let's assume that the sun is casting just two rays. It's a 3D. You have to imagine it in a 3D way. So basically, in this way, this shadow portion, which is cast, this region experiences a total solar eclipse. Eclipse. This is also known as the region of the umbra. Okay. Then one more, because there are infinite number of rays passing, so they can intersect in whatever way. So shadow may be cast in this way also. So two regions are made. One is that of a lighter shadow and one is of this darker shadow. And how are they named? This is known as the penumbra and this is known as the umbra. So the people or the person standing in the umbral shadow, he will observe a total solar eclipse, whereas person standing in the penumbral shadow, he will observe a partial solar eclipse. Fine. And then if I modify, so the rest we have discussed two types of solar eclipse. The next type of solar eclipse is the annular eclipse, in which a ring of fire is observed. Okay. So if we move the moon, so if we move the moon a bit further from the earth, this is also an interesting concept. So here, instead of intersecting directly, we'll have an intersection in front of the moon. So this region, which will be cast, we know that the moon is much smaller. The sun is around 400 times as big as the moon, but it is 400 around 400 times as far away from the moon. So that is why the moon and the sun almost appear equal in size. But during the total solar eclipse, the moon almost appears to cover the sun entirely. But in case of an annular eclipse, if the moon is at a further distance from the earth, then it covers only a central part. A ring of the sun is observed and that constitutes this region, the antumbral region. So this region, so all the people standing here in the antumbral region, they will experience an annular eclipse. And hybrid eclipse is a kind of eclipse in which the sun or the eclipse transitions between a total solar eclipse and an annular solar eclipse. So it is a unique situation. Now the interesting fact is regarding this, that scientists have observed that the moon is continuously moving away from the earth. So right now also, although we observe a limited number of solar eclipses, but in the future, the probability of observing a total solar eclipse will diminish exponentially. Fine. So we have to make sure that we witness most of the eclipses. Now the thing is, when we were talking about the phase of the moon, we say that in the new moon, the moon, we I showed you a diagram where the moon, it appeared, it was placed. Arrangement is known as syzygy. Fine. So in this motion, the three celestial bodies, they are arranged in a straight line. But now what you have to understand is that the plane of orbit of revolution around the sun is different from the for the moon as well as the earth. So for example, if the sun is earth is making a revolution in this plane, the moon's plane will be slightly tilted at about 5 degrees. So just try to imagine, if the moon is revolving around the earth in this direction, the earth is, so there will be only certain situations or certain points known as nodes at which the entire sun, moon, and earth will be in a singular orbital plane, and that will lead to the formation of a solar eclipse. So, this is true. A total solar eclipse does occur always on a new moon, but a new moon does not always guarantee a total solar eclipse. So, just try to imagine this 3D shape. So, if this is the plane of revolution of the earth, the plane of revolution of the moon is around 5 degrees. So the moon is revolving in this way, the earth is revolving in this plane. So there will be only certain points in the moon's orbit when it will be aligned in the same orbital plane, so as to make conditions feasible for a total solar eclipse. And not only should the moon lie in that orbital plane, but it should also establish the condition of syzygy. Fine. So some nice pictures, how a total. So we have talked about this. You can pause and see so this is partial, annular, and total. Fine. So this is how. So we know that the total solar eclipse, it appears only for a brief period of time. So this is the partial solar eclipse. This is finally the total solar eclipse. This ionized plasma gas layer is known as the corona, and it is visible only during a total solar eclipse. And that is why the Aditya L1, that is a solar mission of India. So total solar eclipse is the only feasible way in which the chromosphere and the corona of the sun can be studied extensively. But beads of light, if you can see here, these beads of light basically are due to the reflection caused due to the uneven surface of the moon. Okay. Then finally, that's when the moon is also moving. So finally, we transition to the normal partial eclipse. So this is in detail the radiative zone, this corona, this photosphere. So this is, and this point, the solar wind, which we have been talking about. So this is partial solar eclipse, annular. ring of fire, moon is farther away from the earth as compared to the position in the total solar eclipse. This is totality. Corona is visible. So this is a question for you. Already a lot lengthy discussion has been has occurred. So why does solar eclipse appear to move from west to east? Normally, what we say, the stars like the sun, they appear to move from east to west. But here we are talking about the shadow. I'll just give you a hint. Speed, the tangential velocity or the straight movement of the moon is much faster than the speed of the Earth. Okay, so that is why the moon appears to move faster as compared to the Earth, and it carries its shadow along with it. And due to the curvature of the Earth, we don't have a perfectly west to east movement, but a slight curvature is observed. Okay, so we have discussed this. Okay, orbital nodes. So this was what I was talking about. You can just see here that this is a 5-degree plane in which the moon is revolving around the, and this is if we take the base plane. Okay, so that is why this is solar lunar. Again, not only does it have to appear at the nodes, like here the moon is too high, fine. Here solar eclipse moon is too low, so it should be ideally aligned in the same orbital plane as that of the plane of revolution of the earth around the sun. So this is just a calendar, just an infographic. Okay, Lagrange points, which is important from the point of view of Aditya L1, our ambitious solar mission. So basically, these are points in space where objects tend to stay at their position. So if we are focusing on L1 and L2 Lagrange points. So here Lagrange points, what is speciality? The two bodies here, the gravity of the earth and the gravity of the sun, they are acting in such a way that it appears to remain at its place. So it's not a three-body problem. There is a Netflix show. It's a two-body phenomena. Okay, so this is role of Aditya L1 in solar eclipse research. So this is the solar cycle. So it began in 2010, going to end at 2020. This is the phase of the solar maximum. So greater magnetic activity. So these are just the some definitions and some of the features associated with the sun. I've discussed most of it. You can just pause the slide and have a look at it. So this is an example of aurora borealis. So this phenomena I have explained. It affects communication lines, radio lines, and power lines. Fine. So cause of occurrence we have already discussed. So this is a solar wind, the solar flare or coronal mass ejection when the magnet field or the magnetic field lines of the sun, they get entangled, intertwined, and the activity it increases. There are larger number of sunspots and greater amount of magnetic activity, and it basically the purpose of these magnetic field lines is to prevent the sun's the atmosphere of the earth from the harmful solar winds. And here, due to the high strength of the earth's magnetic field, there the interaction is maximum. And here I have just highlighted or enumerated how the physics and chemistry works. So this was all about the solar eclipse, the types of eclipse, most importantly the solar flares, which have been observed, greater intensity of solar storms. So there can be question in the mains that can be asked in GS1 or GS1 for the point of view of GS1 geography, that they can ask you that what do you understand by aurora borealis, and they can say that examine or analyze the reasons behind the increasing intensity of solar flares or solar storms. So you can attempt this question, you can submit it to me, you can write in 150 words worth 10 marks, and I will check it for you. So with that, we'll conclude today's session. Jai Hind.